All right, welcome back. First, any questions? About the class, that is. We were talking about other things, so that's good. No, okay. So, actually, I'm in the wrong place. All right, I want to talk some more about network security. I think that was it. Oh, yes. Zoom, share my screen. So one thing I was talking about was doing NATing earlier, network address translation, as protecting your local network. I want to talk about some other things. So Wi-Fi. How do you protect your Wi-Fi signals? I can't use physical protection. I can't run the cables in the walls. I can't be monitoring to see if somebody's listening in. You know, I can see if there's a change in the impedance on the electrical signals. I can see if there's an accidental reflection on the fiber optic to tell me, hey, somebody's tapped in and listening into the signal. Wi-Fi, you can't do that. Wi-Fi, you expect people to tap in and listen. And it's being broadcast everywhere. So most Wi-Fi access points require a password and encryption. And I'm not going to go into the details of how it exactly works. There are two different protocols that are used. One was called WEP, the Wired Equivalency Protocol. And the idea here was the encryption would be strong enough, you would have the same level of security as if you were using wires. It's not true. But you know, your device communicates with the Wi-Fi access point and says, I want to establish a connection using the right frequency and everything. And there's a key exchange between your device and that device to set up a session key for you to do encrypted communication. So think of Diffie-Hellman key exchange we did before. It's that type of thing. The problem is the random numbers they use, the random number generator they used is not truly random. Well, they never are. They're pseudo-random number generators, but it's not strong enough. And so by monitoring enough of these connections, you can figure out what the next one will be. So they enhanced it and created WPA Wi-Fi protected access. And there's a couple different modes of that that are at different levels of security. I have an old router at home, or had one until last year, I think it was. It only could do WEP. And people were like, my new devices started saying, nope, we're not supporting WEP at all. We can't connect. Some devices still do. So if we go to strongest to weakest, WPA 3 is the strongest. WPA 2, enterprise and personal, are the next. WPA with AES, advanced encryption standard, or TKIP, trusted key internet protocol, I think. Then web, and then an open network, no security implemented at all. Does anybody ever do open networks? Absolutely. You know, you go to a store and it's an open network. There are a lot of places. Now, someone will do some encryption anyway and not require authentication as part of it. Yes.
So, but there are some open networks that like you connect to and they redirect you to a website to actually sign in and get internet access. Where would that fall into here?
So there's a couple different ways. And so the question was, so people can hear it, there are some open networks you go to, but you don't get full internet access until you log in on a website. Now, it depends how that website is configured, but basically your Wi-Fi signals are still open and unencrypted, but you authenticated yourself to the website. Usually it's an encrypted website, HTTPS. So you're doing encrypted communication to the website. But then after that, it may go back to open so that anybody can observe what you're doing, but they've given you now from that website or they've given you access to the internet, so they know who you are. And it's pretty much for logging purposes, so they know this is what this person was doing, but they don't care about the encryption. So when I go to an open network, I put a VPN, I log in or whatever, and enable the VPN to go through it. So then everything I'm doing is encrypted. A lot more of this is discussed in our network security class and how this works and how this gets broken. I just want you familiar with that. There are many. So that's all I want to talk about with wireless security. Actually, I thought I had a slide. There it is. There are many tools out there, but here's one tool called Kismet. And I can monitor for Wi-Fi devices using this tool. And where's my, there it is. This is what the device that was running could see. These are Wi-Fi access points, a bridge network, the physical, so the protocol that's being used, cryptography that's being used, here's an open one, signal strength and decibels, channels. Wi-Fi communicates over many different communication channels, depending on what frequency you're using. It's like channels 1 through 15, or there could be a whole lot more. If you're using 2400 megahertz versus 52, or whatever the numbers are. Last seen, amount of data being sent, here's the packets, how many clients are connected over that Wi-Fi access point that it can see. So I downloaded this tool on my laptop, fired up my house, and I saw probably just as many networks or devices. But yeah, for my house, I will see my neighbors' networks, multiple networks, multiple neighbors. But this is actually a tool people will use, and they'll go through a corporate network. What do we see? What's available? Is there anything acting as an access point that shouldn't? Is somebody, giving people permission to log in remotely from inside my site? Okay. So like I said, there's lots of different tools out there. I'm going to go back a slide. There is I don't know how many, so virtual machine is how do I describe this? Because we're going to go into this later in the class, but I can run an operating system on my desktop, Windows, Mac desktop, whatever. I can have the machine configured in such a way that it thinks it has a smaller logical desktop or device in it, and run a completely new operating system in that. Okay. And these are typically called, they're virtual machines. So they think they're running on an independent machine. And so I can download a tool. I like personally using VirtualBox. It's free. I then tell it, create a virtual machine for me. And I tell it use, so my desktop has 8 logical processing cores. It's an i7 processor. I said, allocate 4 to this virtual machine. My desktop has 64 gigabytes of RAM. I say, allocate, 24 to this virtual machine. And it has lots of disk space, but I'll say, hey, let's set up a virtual disk. Let's allocate 256 gigabytes to this virtual machine. That's probably a lot more than I need on a virtual machine. And I say, run it, and then I install a new operating system in there. Then I can do whatever I want inside that virtual machine. And if I don't like it, I can destroy it and start again. Of course, anything I had in it is gone, but my main desktop still exists. So on my desktop in my office, I regularly run lots of different virtual machines for different purposes. I have a Windows virtual machines, I have Linux virtual machines, I have multiple versions of Linux virtual machines. I have one that pretends it's running on an ARM processor versus an Intel processor, lots of different things. I have a server in my office that runs 4 different virtual machines that I remotely log into and do things on instead of the main desktop. People create these virtual machines and create images and say, hey, here's a copy of everything I've installed, all these applications, all these tools, and I'll put it out there. You can download it and start running it on your machine. You have everything installed. A popular one for cybersecurity education and practice and play is called Kali Linux. And so here's a link for it. They recommend a minimum of 4 GB RAM and 20 GB hard drive. It must run on a 64-bit system, 64-bit operating system. It used to be 32. They've given up on that. It can be downloaded. It has instructions for how to install it using VirtualBox. And it has all these built-in cybersecurity tools already installed. It has Wireshark in there. It has Kismet. It has a bunch of other tools. Some of the more advanced classes will have you actually run and use it. But it's a very useful thing. If you ever want to play with some of these tools, they'll probably be there. I give it a minimum of 8 GB of RAM, a minimum of 40 GB hard drive space just to be safe. And I tell it at least 2 processing cores of my machine. All right. There are tools out there called scanners. They're used to see what devices are on your network. Nmap is one that scans for machines and open network ports. So if I ran Nmap here, right, and I'm looking at my local machine, like just said, I told it just run it on the machine it's running on. It tells me, hey, I have these ports, port 22, TCP port 22, TCP port 53, TCP port 80, TCP port 631, TCP port 336, all open, listening, waiting for connections. And they said it happens to know what these ports are. This is SSH, this is domain name services, this is HTTP, this is IPP, and this is MySQL. So these, on that machine I was running, those are the services it has running on those ports waiting for outside connections. And so I ran it and it just found this information. It stored it in a file called MyScan. So this was, I was just listing and showing that it saved it there so I didn't have to rerun it every time. There's lots of different ways of doing this. I can use Nmap to say, tell me what this other machine on my network is running and making available. If you do that and start scanning too many machines, too many ports, ITS is going to shut you down. In a lab, we can do this. In your own home, you can do this. On public networks, be really careful. Okay, but it's system administrators will use this on a regular basis to say, hey, what's running on our network? What services are out there? Who is fired up a web server that's not authorized? Now, what Nmap does is it just goes out and it says, makes a TCP connection to port 80 and says, hello, anybody there? And then waits to see if there's a response. So there are other tools, which we call packet sniffers. I talked about like Snort earlier, but you can run a packet sniffer to show details of all network traffic. There are simple ones that like TCP dump that are all text-based. There's more graphical ones like Wireshark that's a graphical user interface that shows you a lot of things. There's also a library, libpcap. If you write some code, you can interface with this library and it says, hey, grab data from this network interface, do things with it, and you write your own tools. PCAP also, you can use a tool like Wireshark or TCP dump to capture everything, store it in a PCAP file, packet capture file, copies of the network traffic, and then write your own tools to analyze the network traffic at your leisure. There's also lots of examples of those packet capture files out on the network. Hey, here's one that had this type of attack in it. Here's one that has this type of normal traffic that you can use your tools and experiment with. And those are the ones I have my students use. It's like, hey, don't bother monitoring the live network. Let's look at these examples of things so you know what you're doing. So intrusion detection systems are built to read these things and use these libraries. Lots of tools out there, lots of capability. If you ever want to have fun programming things, tap into something like this. This is really fun coding. It's hard. It's a lot of work. But here's an example of the interface for Wireshark. And it's just running on a network. And here, for example, I have a domain name service query from machine 192.168.0.21 sent to 129.168.0.1, making a standard query. And then if I click on this, it shows details. These are collapsed. I could expand these to show full details, but this shows it's an Ethernet frame with 489 bytes on the wire. It's version 2 Ethernet, and it shows the MAC address of the source and destination. And it says that this is a global network card, serial number this is a Vizio card, network this. It's Internet Protocol version 4, source IP, destination IP. It's a user datagram protocol, source port 53, destination port. So this is a response to me. And then here, it was a name service request, and so response. So I opened that up to see what it was. It's the actual request was in packet 348. This one is packet 349, the response, or line 348, 349. How long it took, attraction identifier, the flags, and all the information. Here was the query we had, and it gave an answer and shows all the details. And if we highlight, we can see, you know, transaction ID is 2188 hex. That's where it is in the raw hex of the data. Here's like images.netflix. That's what I was looking up, etc. And so you can dig down in this using these tools. What was really on there? And the nice thing about the tool is it decodes most of this stuff for you already. So you don't have to do it yourself and write your own tool to do all this. And there's interfaces where you can make add-ons onto this, where you're going to have this dump this data in a separate file, which you can then analyze. Say, okay, it did this much. Now here's what else I need. Up here in the command line, there's places you can put in filters. Say, I could filter and say, just show me stuff going to my machine. Because you'll notice I'm machine 0.21. There's a lot of that in here. Actually, this one doesn't have anything not to my machine. But maybe I'll say, oh, only show me TCP. So we'll throw out the UDP stuff, or show me only web requests. And it'll only show those. And so these tools exist, and that's the nice thing. And there are things to play with, and Wireshark is again free. There's so many of these tools that are free. I don't know how people make money with them, but
does any of the information go back to Wireshark after you're using it?
No.
There's no such thing as a free lunch.
I think they have additional services you can pay for.
Okay.
Sometimes like, hey, here's a standard interface now. If you want the add-ons, then you pay. But there's also a lot of people who just put these things out there as part of a service to the community. And here's an example of one I know I was helping with at one point. So they had this tool out there. They put it out, made it free to the community. And they said, you know, and then I said, oh, but it doesn't do this thing. So I went and added that feature to it and made it public, you know, added it to the tool. So we shared with each other. Their benefit was I added to their tool and gave them an extra feature. My benefit was I didn't have to write the whole thing from scratch. And so the whole community, you know, the community helps each other, and we all benefit by getting better tools that we can use to do our jobs. It's socialism, but you know, because it's sure not capitalism if you're not making money. But it is a very useful thing, and there's a lot of tools out there for doing things. There are tools that also map the topology of your networks and firewalls. One example is a tool called SCAPI. What it does is uses Internet Control Message Protocol to examine the network. It can evade some normal security measures. That's spelled wrong, but can be used as a standalone tool or can be scripted. And again, it's just, what can get through your firewall, what can't. It's a way of analyzing it besides just looking at the standard firewall rules, see what actually can work. There's some more advanced tools out there called honeypots and honeynets. You set up a fake computer or a fake network, no real users, no real data, and then you instrument it like crazy to see what's going on. I'll put a honeypot on our network, so it's just another machine on the network running things. When an attacker tries to come in and do things, there's no legitimate use of this machine, so every attempt to use this machine is an attack. And I see what they're doing, and I learn what they're doing. And sometimes you can put in small vulnerabilities in there or leave older code on there to let them get into the machine and then see what they do. You do this with authorization of your organization that's running your network. You don't put a honeypot on to your normal network without permission, because if they do get into it and then use that machine to launch attacks against legitimate machines, you have some problems. Some people will set up a full subnetwork or network of a collection of machines, or a pseudo collection of machines. It could be one server running a bunch of VMs, but it looks like separate machines running this, again, to monitor what's going on the network. And the honeypot is you put something out there sweet to attract people. You have to be careful. So a friend of mine worked at University of Washington. This was many years ago, probably 15 years ago. He set up a honeypot or honeynet. He was monitoring botnet traffic. So his machine was attacked. He knew what vulnerabilities they were using. He left those on the machines. The machines were attacked. They installed the botnet software on there. He was looking at now the command and control they use. So again, just to reiterate, botnet is I attack your machine. I install a small piece of software on your machine. I have a command and control server somewhere. Occasionally, the piece of software installed on your machine contacts the command and control server and says, what do I do? What do you want me to do? And I may say, send the spam email. Do this distributed denial of service attack against this other thing. Turn on a keystroke logger, whatever. Botnets out there usually have tens of thousands of machines on them, and they're for rent. So you want a botnet to do some type of a denial of service attack, come to botnets.rs and I'll rent one out to you and for a brief amount of time. You want to send spam email, I'll rent out that service. The command and control network, to make sure that the authorities don't see what's going on, the communication is encrypted. They move around where that server is. The smart ones will have a list of different IP addresses encrypted within the bots. Say, hey, go to this one, then this one, then this one. After a bit, they go to the last one, say download the next list of several IP addresses were used to try and stay ahead of the authorities. So my friend was researching all this, seeing what are they doing? Let's find this command and control network. And he said, I'm going to query this. I'm going to create a fake data packet from the bot to this network to see what's happened. Well, the makers of these botnets make very reliable tamper-proof software. So their intrusion detection system detected him intruding on their network. They traced it back to him at University of Washington. They then did a distributed denial of service attack against University of Washington main campus, then contacted them and said, we will keep this up until you shut down this researcher. And so they shut down the researcher because the whole campus network was brought down. So yeah. So he then got funding from a private company. They set up a completely different network, independent University of Washington, and he continued doing his research that way. And so if they caught what he was doing, it was an independent network. They couldn't figure out who owned it and who to blame. Yes.
So the book says this is controversial. Why would that be?
What's controversial? Honeypots, honey nuts?
Yeah.
Some people claim it's entrapment. You know, you tempted me. You made me do this. I was like, yeah, I set out my jewels on my kitchen counter and you just broke into my house and steal them. That's my fault. Apparently. So a related, but a real story that tells why people get away with this. You know, two of them. One, somebody broke into a house. They go into the person's kitchen. There was a sharp knife out on the counter. They touch it. They cut themselves. They sued the homeowner for having an unsafe kitchen. And it was actually considered a valid lawsuit. A friend of mine, a man broke into, so she's sleeping in her bed. He broke into her house and attempted to rape her in her bedroom. She escaped out the window. She calls the police. Somebody broke into my house. One of the first questions police asked her was, what were you wearing? And she's like, I was asleep in my house with my closed window. I could have been naked. It doesn't matter. He broke into my house. Yeah, but, no, but. I wasn't tempting him. I was sleeping in my bed and he broke in. It wasn't like he was a boyfriend in there with me. It was. So there's sometimes these attitudes. And that was back in the 80s, by the way. So hopefully things changed by now. I doubt it. But unfortunately, she wasn't harmed. Scared to death. But so yeah, the controversial is, are you tempting? Are you setting something up to attempt somebody to do something? Again, it's my computer. I didn't advertise and say, here's my computer, try to break in. Aha, you broke in, now you're in trouble. But it is controversial because some people believe that's that. The other thing is there's a group of people who believe data should be free. All information out there should be free. There's a group of hackers that say, you know, all software should be free. They fully believe this and they post these manifestos. Data should be free. We have a right to access that data until we try to figure out who they are, then they want that private. All right, I got some more things to share, but I wanted to do that. Any questions on that?
So the question kind of goes back to Tuesday.
Yes.
I won't say where I worked, but I worked at an organization and they weren't real keen on me bringing my personal equipment in.
Right.
But the equipment that was provided didn't have near enough horsepower to do what I needed to do.
Right.
So I brought my own laptop in, needed files on the network, of course, couldn't connect to the Wi-Fi, but I was able to plug into the Ethernet port and gain access through that mechanism. Is there any real reason? I mean, I was using the same credentials that I was trying to use on the Wi-Fi. Does that make any sense, or was I just kind of lucky that that worked?
So it makes it, you're lucky it worked. If they should have had MAC address controls at the switch that prevented you from plugging in a separate device.
Mm-hmm.
Two, you were violating corporate policy and rules, so you're at fault. And you could get in trouble for that, even if I need this to do my job.
Right.
But it's like you said, I cannot do my job without this new equipment or my own equipment and talk to them. But yes, but no, their switch should be a smart switch that says only these authorized MAC addresses actually can connect on this port. So it wasn't configured securely enough. So people could do exactly what you're doing. Because also once you're on that port, you could do some spoofing and some other things. And especially if they didn't have strong credentials for you logging in, who knows what you get access to.
Yeah, I noticed some things that weren't on my standard.
Yeah, there's lots of things you can notice if you start snooping and being very, very careful, because you could be breaking your corporate policy. At least the simplest thing is get reprimanded, could get fired, could get sued. Did I talk to, good.
Oh my God, there's also the chance that like the computer is already infected and then you log onto their network and.
Yeah, if your computer's infected, and without realizing you've now infected the network, it goes both ways. The network can be infected and infect your computer. It's hard. We want to get our jobs done. We want to do it effectively. It's hard, yes. All right. there is, I will share this. An organization, a university, has set up what they call the NCAE Cyber Games, National Centers of Academic Excellence, Cyber Games, c2games.org. This is something, if you want to play with, you're welcome to. You try to register, they'll send me an email, say, is this a student at your university? I'll say yes, if you're a student at our university and you can play with it. They give some information about what this is. This is supposedly entry-level stuff. It's not as easy as they say. There's a how to play thing. They still don't have the link here. I told them to put this link in. So if you, okay, I'm going to open up a new tab, maybe if I can find it. PMP, pacmanplay.c2games.org. Okay, because I forgot the period. Is a faculty member at a university, built this game to teach people about how networking works. I want to walk you through a little of this to show you some of what's going on. Okay, unfortunately, it's a WebGL and apparently it's slower on this machine than my machine. Wow, much slower. So what he does is, you're familiar with Pac-Man game, right? This has, it looks like Pac-Man has nothing to do with the game. All right.
Are there strawberries?
What?
Are there
I don't see any strawberries. So what we have here is a tutorial in different levels, right? And here's Pac-Man. Here's a network card. Here's a console. So if I click on the tutorial, okay, I don't know, I can start the level. It gives you some information what things are. Here's a network packet, website, other things. So we're running on the network and it gives instructions. We can interact with the network interface card across a chain of routers to successfully ping pacmanping.com. Now, what do I mean by ping? I'm gonna turn off the audio on this. Let's see. I need to know if your machine is up and running. One way to do that is to run a command called ping. Ping based on sonar in submarine. So I ping you, I will do ping pacmanping.com and it'll respond with a data message that tells me it's up and running. If it doesn't respond, it means I have no access to it for one reason or another. So if I say, hey, let's do this, find pacmanping.com, what this will do is it redirects me to the actual address and I go out over the network and get to an intermediate file, a network card. This is my router. And I tell it I want to find pacmanping.com. So it goes to the next device on the network because it knows which route to go. And this one still want to go. So it kind of shows you just what it's going. And then if I looked at the actual website or the terminal, I could see what I have. Okay, kind of boring. And now I can have this say, hey, I want to send the response back and see that packet here. That's going back to my machine saying, oh, here it is. If there wasn't a tutorial, it asks you to do some other thing. Okay. So, and there's the network setup. So I'm gonna ignore that. If I go to, oh wait a minute, that's the other guide. Menu, that's it. Exit main menu. I want to now deal with addresses. So if I go to my, let's start the level, sorry. Say I go here, I want to run, it says You don't have an internet protocol address. You need to do something to get one. You should go to the console and tell it, I either can request an IP address using dynamic host control protocol, or I can configure one manually. So I say, hey, I'll do the dynamic host control. It says, can't do it. No server set up. Okay, bummer, I failed. So I try again, click on that. Statically configure it. And it tells you what I need to do. It says, hey, I'm gonna assign myself an address. Details are important. So I selected device number 7 on my network. And I happen to know I'm on network 192.168.23. So I will give myself address 192.168.23.7 and create a subnet mask for the 24-bit, 255.255.255.0. And so it walks you through this, but it doesn't tell you how to do this. It just says this is kind of the things you have to do. And there's several of these steps. The reason I'm showing you this is part of the game and what I wanted to show you. If I go to the sandbox, I could create an environment. I have one that already exists and I can launch it. Now, what it gives me, actually usually is this, is a remote machine interface. They should not show this to introductory level students. It's ridiculous. But I click on it and I say, oh, this is my sandbox. So my data center, I've got this sandbox of a collection of virtual machines. The one that's lit up here is mine. If I click on it, it shows me all the information about what's going on in the device. But the important thing is this console here. I am now running on a virtual machine with a remote desktop console, graphical user interface. Uh-oh, no password. Well, let's try password. Well, that worked. Because it's a game. This is not a real machine. It's not connecting to anything real, but it's there. And I can play things with it, and I can play with it. I'm trying to think. There was a way of actually getting a standalone console. There we go. So I'm going to shrink this one, make this one full size, and then you probably can't. Please give me full size. Where is this? Oh, it doesn't get any bigger, does it? Okay, so I was hoping to be bigger. What you see normally is this user interface for a version of Linux called Ubuntu or Ubuntu. Yeah, it doesn't let me zoom or anything. If you click down here on this shows you all the applications you can run, and terminal is your command line interface for Ubuntu. If I type something like ls for list, it shows me the different directories or files. Okay, these are things you'll need to learn how to do if you do any system programming. Okay, and there's a whole lot of things you can do with Linux. But I wanted to show you, and this is not, actually, I got an idea. That's not any bigger for you guys, is it? I was hoping if I just shared that small screen, probably bigger for the Zoom students, but okay. How can I get this bigger? That's funny. There we go. That was my phone. Sorry, I forgot to mute it. My friend Spam. So if I type in IP ADDR for address, it shows me some information about my network. So it mentions here the network card abbreviation. So LO is loop back, it means local machine. IP address 127.0.0.1 is by default yourself. No matter what your real IP address is, this always contacts your own machine. This one, ENS 18, happens to be the number that this virtual machine is using. It's on Linux machines, it's usually EN something like EN 0, EN what. This one happens to be ENS 18. It tells me stuff about it. It shows me the MAC address of the machine. It shows me its internet address is 192.1.1.24 and broadcast of that. My IPv6 address is this one. And it tells me how long these are valid. But that's not the address I want. How do I change it? There are different ways. And unfortunately, every couple years, they modify how to do it just to keep you on your toes. Usually, I could click on an icon up here like the wired and say, hey, I've got this wired network. What are the settings? Let me change them. And somewhere over here is my network settings, but it's not letting me do anything. Usually I see more stuff here. They hid it on this because they didn't, for this tool, they didn't want me doing this. So if I look in the directories, there's like a directory called etc for etc, etc, that has a whole lot of things that are standard in a Unix environment. If I look in /etc/netplan, there's only one file. I can look at the files using a program called more, or I can use a program called less, more or less work. But more basically, prevents me from scrolling past the screen. I have to hit space to go further. This one's not a big file. So if I did more, for example, if I did, let's see, if I looked at the password file. Oops, I dropped the backslash. No such file or directory. Oh, cool.
It's past WD.
You see, it stops and then I can go further. We'll talk about this one later. Okay. Clears the screen. So here's the default network configuration. It doesn't do anything because it basically says do everything automatic. I want to change this. So how do I change it? I edit it. An editor I like to use is called VI. There's Nano, there's Vim, there's a bunch of others out there. Emacs. I'll just use VI for this. The command sudo that you see here that I'm typing in, sudo says act as if I am the super user. Super user do. I have permission to log in as super user to the root owner, the system administrator, to edit certain files. Normally, as a normal user, I can't edit this. It asks for my password to make sure, so I have to do that. Well, we know that's password, so that's easy. I'm in, I can do this. Let me make the changes here. I should be able to do this. I'm going to say I want the network daemon to run. And I just Googled editing NetPlan to figure out how to do this. Okay, network D. What machines? What networks do I need? So Ethernet. I had ENS, what was it, 18, I hope? What internet address did I want? I want 192.168.23.7. And the network mask is 24 bits. And I could stop there. Or I could go further and I could say like my name servers, where do I actually get when I look up google.com? And I could say, well, there's a set of these. So maybe mine's 192.168.23.1 is the name server. I'm just guessing. But it could be something like that. One of the modes actually tells you which one it is. And you can put that in. One of the levels, okay. Now I'm gonna say, let's do NetPlan. Let's try this to see if it works. There was an error, okay. Minus D for debug. Well, that doesn't help.
I think it was a space. The rendered space network.
I'm sorry.
Out of space
Ah,
after
you
that.
think it's here?
Yeah.
Error configuration could not be generated. There was something there. Expected sequence. We need a dash. You want to keep these settings, enter before time out to accept the new consideration. So I did it. Now if I type IP address, down here, I'm now 192.168.3.7. So I've changed my network address. Okay. Yay, I win. All right, what else can I do? What else do I want to do? Firewalls. Lots of different ways of configuring firewalls. On Unix, there's now something, a universal firewall tool that is much nicer to use than the old ways. If I look at more, etc., if I look at it's etc, come on, default /UFW. This is a default configuration for my universal firewall. It tells me, yes, I use IPv6. It says default input policy drop, default output policy accept, etc. So it has some information in there. How do I use it? You can do this on Google or you can do this on a command line interface for Linux. You type man for manual. So man UFW, and it gives me instructions of information about it. Its name, description, the usage. This is standard user interface type thing. I could use UFW. This is an optional command, the square brackets, and then things I can do. Enable, disable, reload, default, logging, reset, status, and then some other things. And then you can go, this is the summary of it, and then it gets more details in the options, explains what they do. Okay, so I'm going to clear this and just show you some things. I could tell it, again, I have to do this all as root, so sudo UFW for default, I'm going to tell it to deny all incoming packets. By default, oh, how did I get the whole line back? I hit the up arrow and it just shows me the last command. I can, let's see, accept everything outgoing. Whoops. Allow, not accept. Wrong tool. Okay. What else do I want to do? Let's say I want to allow somebody to remotely log in. By default, I'm saying nothing, but I want them to SSH in. I could tell it allow port 22, TCP port 22. That's a default. Or I have the ability, UFW knows certain applications, Apache web server, cups, and OpenSSH. That's all it knows for this tutorial thing. So I could say sudo UFW allow OpenSSH, and it'll allow the different rules. I can now turn it on, enable. It says it's active. And then I could show it status. I could type status. And it tells me, oh, we're allowing OpenSSH from anywhere, both version 4 and version 6 Internet Protocol. I could tell it, hey, give it to me numbered. And it shows the numbers of them. I could tell it, hey, let's be verbose. Verbose is a good command for a lot of things. Whoops. Need a space. And it tells me, oh, the default is deny incoming, allow outgoing. So it gives me more detail. And notice here now, it's also saying the actual port numbers we needed. It's port 22. I could be very precise. I could say UFW deny any protocol TCP from a, let's say 10.0.0.0/8, anybody from that subnetwork to me, 192.1, let's see, 168. 23.7, port 25, that's my email port. Or I may make port 22. Oops. I had an extra period there. Oh, I forgot to do it as root. So that becomes, I can allow anywhere in, I deny it. Okay, the order's wrong. Because it'll do first come, first serve. I should fix that. Or maybe I just said, oh, I'll change that. So let me do this numbered. Okay, forget the verbose. So now I can do sudo UFW. Let's delete rule 1. So now I deny them to come in. And now let me allow OpenSSH again. And notice there was a duplicate rule, so it didn't add it, but it had the rest. So we have version 4, version 6 rules of OpenSSH. So first, these people can't use SSH to come in, but everyone else can. And so I can play with these different rules to do things. Now, I put these all in. I need to make it active, so I apply the rules. Now they're all available. And there's sometimes you have to system control, CTL, restart, say the network daemon, just to have it completely done. Okay, that wasn't the right one. Let's try network. What was it? Network manager. That just resets the network manager to make sure. Sometimes you just have to do this for it to absorb all the rules and start using them. It should have handled that, but on the tutorial, sometimes I found I had to do that to apply my net plan or other things. But I showed you the net plan apply usually does that for you. Anyway, I have my rules. I have everything set up. I could reset the firewall back to the default, get rid of all my rules. Now notice these, it's saying backing up user.rules, before.rules, after.rules. There's a more detailed firewall built into Linux that uses these. Before.rules, it's as the packet comes in before anybody else touches it, it applies that. Then something else happens, and then the after.rules can be applied. There's also user.rules, whole way of doing that. That's where people get lost. So it's much easier to just use UFW. Yes.
So earlier when you removed the rule for the version 4 OpenSSH, what did that do with it? Because before it was denied and then you allowed it. So then what does it happen when you just forget to delete the rule?
I'm sorry. So when I deleted the rule,
Yeah.
it just basically said OpenSSH was not allowed to anybody on IPv4. And then I put it back in. But now that I put it in a different order, so this one is done first, then this one. So it will deny people from this address first before it allows anybody from anywhere on the rest of it. That makes sense? So anyway, these are tool UFW is available. You know, you can play with these things. I was trying to think what else is there. So in that Pac-Man ping game, they show these. They also have you do some other things in terms of like editing a firewall rule or a domain name server. You look at it. Oh wait, there's a typo. I fixed that. But it's a fun thing to just kind of play with. More advanced ones will have you running multiple machines, communicating with each other. Now on this one, let me actually. If I did the right thing and I set myself up for that address, let's go back to my Pac-Man ping game. Where'd it go? Let's see it. Oh, that's because I'm on the wrong share. Okay. So it showed that it has things. Let's see where all the traffic goes to look for a flag. Investigate 192.168.23.101. Heading to this. I want to see what this does. So I'm on the right subnetwork now because I'm on my 123.7. This one sends me over there. I can look at this console. Let me try it. Stay here. That's one interface I don't like. I don't have internal terminal access. That's useless. Let's go to its website. Oh, look, computer's running a website. Let's try viewing the web contents in a browser. Connecting 192.168.23.101. That's the browser. Okay, so I'm going to go back to this thing. I'm going to first type ping 192.168.23.101 to see if I can even see it. But pint, yeah. Typos are good. Oh, wait, and of course, the there you go, share my whole screen so you can see it. So notice it keeps sending responses back. So I can see the machine. Control C to stop. Where's my terminal? I didn't exit the terminal so I can just see what I'm doing. I have a browser. I can, hey, let's check out 192.168.1, 23.101, right? Hey, made it to a website. Princess is in another castle, go away. Okay, I'll send you a flag, but only send files securely. So you have to configure an SSH server on your Ubuntu machine. You should have SSH already installed, just need to configure it correctly. By the way, I'm sending a flag to a different network, 192.168.42.0 network. So I got to change my machine to 192.168.42.7. I got to enable port 22 on my firewall. And I got to do something in the SSH server, and there's ways of doing that. So this is how this game works. And then what they do is once you do that, it copies what they call a flag file to your desktop. And if this was a normal cybersecurity competition, you would submit that flag file to the scoring server, and they'd say, yes, you got the right flag, move on. So that's kind of how these things work. So configuring SSH, let's go back. My guess is, let's see. If I look at it, Etsy says SSH, yeah, there's SSH _ config. That's what it looks like. And it turns protocols and stuff, but there's something missing in here. Let's see. I think I just have to turn it on, but I have to get the right address first. And so it's usually something like service control CTL SSH D start. Oops, got to spell start right.
You got sudo.
Well, you know, good thing you can see I can't spell passwords. Okay. System control. Let's call it system.
Yeah.
There's so many different unknown operation SSHD. Let's try SSH. Unknown operation. Okay. I would Google it. I don't remember. I forgot to put that one on my notes.
I thought it was SSH.
But how do you start it, right?
Yeah.
You have to turn it on. Let's see. So I would do something like start SSHD service.
SSHD dot service, maybe.
Oh. System controls, right. Say start first. Fail because control process is with error control. Something's wrong because there was a typo in the config file. So status SSH dot service. And it said bind to port 22 on 1.1.1 failed. Oh, 1.1.1 is not my machine. So somehow the SSH configuration is not looking at the right IP address. So, oh, which also tells me that I better modify the YAML file to give me the right IP address first, then make sure it's loading on it. So anyway, you Google that and you say, oh, where is it? My guess is, right here, host star. I probably should change that to be me. So I have time, so etc. Said net plan. That one, I'm going to change myself. It was 42, right? Yeah, yeah. Well, yeah, you watch the video game, you play that, you write your notes down, then you switch over to this. So what's my IP address now? Make sure I got it right. Yep, I'm network 42. Yeah, etc. SSH config. Change my host. One 168.42.7. Run it. Status SSH service. It didn't like it. Should have worked. Start again.
Did you run the old?
Oh, I did I did status. Right. That was the old. There it is. Where is it? Started. It worked. Nope, it still had an error. Huh. That one I'm not sure. Did I save it? The file? Yep. Oh, something still failed. So type of thing to play with, you know. Like I said, I had my notes on this. I finished all 7 levels earlier, so I know I can do this, but I forgot my notes. And usually just Google something, figure it out. The beauty of these things is you do get to figure out what the current way of doing this is. Not the way I'm used to doing this at all. I have completely different tools I use, but they're not available on this machine. Journal CTL-XE. Sudo, what was it? Restart the network. D. Manager. There you go. Hey, you know, sometimes it's what you need to do. Yeah, there's just a bunch of different things to restart, reconfigure. Maybe my IP address is wrong. Nope, got it right. So why that one's failing, I don't know. And I figured it out last time. Anyway, that's about it for time. So just show you these things exist. You can play with them. They're fun to play with and learn it. And even your instructors don't always know all this. And that's okay, I hope. All right, any questions? So we're going to switch next time to operating system security.